I'm going to do a demo of a equilibrium constant question. This is done on the PowerPoint, but I want to do it a little more slowly just to explain the concepts. Okay, so an ICE table, ICE, initial, change, and equilibrium, are only used if you need to calculate a new concentration. X represents the change in concentration as the reaction reaches equilibrium. And we always plug concentrations in molarity. So there's going to be some times when I give you moles, but it has to be put in concentration. So it has to be moles per liter. Okay, so just make sure you're always doing that. That's something that's going to trick you. Okay, so the equilibrium constant for the conversion of cis stilbene to trans stilbene is 24 at 200 degrees Celsius. Suppose that initially there's only the cis stilbene is present at a concentration of 0.85, big M means moles per liter. Calculate the equilibrium concentrations of cis and trans. Okay, so it said it's in equilibrium. So we have cis stilbene in equilibrium with trans. Sorry, am I writing there? Trans. I think I have lots of S's there. Okay, so initially we started only with the cis, okay, and we had 0.850 moles per liter. Okay. When we initially put this in a container, we had no trans, so we put a 0 there. Then change. We needed to add some x. And the reason I do x is I assume this is a balanced equation, like there's a number 1 here and a number 1 there. And I am going to, sorry, this should be subtract x, because some of it turns into or goes through the reaction to become the trans. And we put minus x. If there would have been a 2 here or a 7, we would put minus 2 or we would put minus 7x, okay? Now I'm messing myself up. Plus x. There we go. Okay, and now I do the math on the bottom. At equilibrium, it's going to be 0.850 minus x. 0 plus x is simply x. Okay, we know that the equilibrium constant is always the products, the concentration of the products over the concentration of the reactants. In this case, it's trans is our product. I'm going to get rid of that 2 I put there. And cis is on the bottom. Because there are no coefficients, we don't have to add any squares or cubes. If there was numbers in front of the equation, we'd have to add those things. Okay, but that's not the case here. So now we are just going to put in the values from our table and the values that were given to us. Sorry, I just have to make sure that shows up so I can stop recording later. Okay, so we were given the equilibrium constant to be 24. So I'm going to put that value in. 24 equals trans is simply x. 0.85 minus x is trans. Okay, so now here I have an equation. I have one unknown, x. I'm going to try and solve for x. This is a linear. Okay, cross multiply or multiply both sides by the denominator is going to get rid of my fraction. So I have sorry. Okay, so I cross multiply, I get 24 times 0.850 minus x equals x. Now I need to distribute, I need to apply this 24. So we're going to have to get out a calculator. So I need 24 times 0.85, and I get 20.4. Minus 24x equals x. To get x by itself, I'm going to add 25x to both sides. So I'm going to get 25x. I added 24x to both sides. Solving for x, I'm going to divide both sides by 25. Okay, so then I will get x, 20.4 divided by 25. Divided by 25, and I get 0.816. Okay, this question is not done. That is just my value of x. The question asked us for the equilibrium concentration of cis and trans. So I know that trans is just x. So the equilibrium of trans, the concentration would be 0.816 moles per liter. But to find the cis, I have to take 0.85 and subtract x. 0.816, oops, sorry. 0.850 minus 0.816 will give me my answer. So 16 going to 50, I think I need another 34 moles per liter. Okay, and that would be your final answer there.